All right, welcome back. So this is an ALEKS topic that's called stoichiometric coefficients. And this is a really good topic sort of as an introduction to balancing chemical reactions and understanding what all these little numbers mean and sort of the differences between them. So I think it's a great topic and definitely one that you absolutely need to understand this basically to move forward in chemistry. So the question here says, what is the total number of oxygen atoms on the left-hand side of this chemical equation? So just orienting ourselves to this balanced chemical reaction, the left-hand side, also known as the reactants side, is going to be over here. So these are what we call the reactants. This would be the left-hand side. Over here on the right-hand side of the arrow, so this is reactants, this is going to be products. So then on the right-hand side or product side, we should have, again, the same number of atoms on each side, right? So to be balanced, we have to have the same number of atoms on the left-hand side as the right-hand side. But we need to be able to count how many different types of atoms there are. So that's sort of the point of this topic. And then in future topics, we'll sort of push that a little bit further. So we're asked to count the number of oxygen atoms on this side. And basically, I see oxygen here. I also see oxygen here. And I see all these little numbers. So basically what we need to do is we need to be able to figure out what this means. So I'm going to write 2 Ca2 parentheses PO4 2. And in this sort of piece, in total, there's going to be 4 oxygen atoms for each one of these phosphates. So in this inside of the parentheses, this is a phosphate polyatomic ion. So this PO4, there's 4 oxygen atoms for every one of these. And then there's 2, this little 2 indicates that there's 2 of these PO4 pieces, basically. So because I've got 2 of those, then that would indicate that I have 8 phosphorus atoms for every one of these. And then since I have 2 of those, that means in total there's going to be 16 total oxygen atoms. So again, just running through that again, this big 2 on the outside means that I've got 2 of these whole things. So you could sort of imagine, putting something like this. So I've got 2 of these whole things. In each one of these, I've got 8 total oxygen atoms. There's 4 in each one of these pieces, but then I've got 2 of each of these pieces, which makes 8. 8 times 2 is 16. Over here, I've got 4 SiO2. So again, in this piece, I'm going to have 8 total oxygen atoms. In each one of these, I've got 2 oxygen atoms for every one of these silicon dioxide molecules, but then I've got 4 total of these SiO2s. So then that means I've got 8 total oxygen atoms. So that's how we're going to sort of deal with this. That's how we count these numbers. And then I just add these up. We should have 24. How many? 24. That's all we put in. All right. Hopefully that helps. Cheers.